removed phosphorus, does the water not contain many of these reagents that you have used in the process of water purification? That you must address. Otherwise, though you have gained something, but then if those are not removed properly, then you have contaminated. And was the acid really very required, and to what extent you have used the acid? These are the points that you must address, I feel. Thank you.
Do you have any response for that?
Sulfuric acid or antimony are not used in purifying water. Am I okay?
Sir, I am clarifying the subject. In the experiment, sulfuric acid, potassium antimony tartarate, and ammonium molybdate are not used to purify the water. These reagents are used to determine phosphorus present in water. We use
okay, but you have, okay, I think you stop it. This is all right. But you have used alarm.
Yes, if we consider.
But then in this process, you have introduced lot of aluminium, lot of potassium, yes, lot of sulfate.
I think just to clarify a little bit of point here, I think objective of their objective was to compare. I think that's a very good point made about that artificial contaminant that may get into the system. I think they are trying to compare how alarm, which is conventionally used in treatment plant, can remove phosphate, and they are also using soil columns to compare that. I think that's a very good point made about sustainability. I think that is well taken. Yeah, thank you.
Thank you.
Any other question? Do you guys have any question? No? Does anybody have any other question?
Excuse me, can I ask a question?
Sure.
Yeah. They said that they have mixed charcoal they have used charcoal to remove the phosphorus from the solution. But if we have found that when we use the charcoal powder, it was very hard to remove the color, the blackish color from the solution. Then how have they removed the blackish color from the solution waste?
Using cotton. By using cotton.
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 By using cotton.
Yeah.
Yes.
I think just to clarify here, I think they are using a filtration system to remove it. Also, if you clean the circle properly, if there's a pre-cleaning process per circle, there will not be any color left. Circle is very commonly used in water treatment, and if you treat them well before you clean the circle properly, there will not be any color left.
On the charcoal, Achinto, I think they might like to mention that whether these are animal charcoal or
sure,
other based charcoal.
Sure, definitely, yeah, definitely. I think that's the whole purpose of what we are going to do after this presentation. We are going to give them some feedback about their strengths and weaknesses. So I can see a lot of strength in their work, very less weaknesses, because they are all 10th grade and 9th grade and 10th grade students. So we'll be pointing out some stuff so that they can improve upon this.
Very right.
Any other question? Okay, thank you very much. Now we have the presentation from Team Nagaon. Can everybody mute their microphones except Team Nagaon? Yeah, we'll have the presentation from Nagaon now. The team from Nagaon, this is the Nagaon Girls High School. I think I got it wrong. Hold on for a minute. Yes, sir. So, I think the first presentation actually is from Nagaon Sankardev Niketan. So, after they make their presentation, will you be presenting in English or Assamese?
In English.
Okay, that's fine then. Okay, so first we'll play your video. Play your video. Then we'll go for the presentation. We are playing your video right now.
মাথাউৰি ছিঙিলে ঘৰবোৰ নেদেখাও মোৰ বান্ধৈ ঘৰবোৰ নেদেখাও
This is a very good song about water problem in Assam, in India.
Yes.
So we'll start your presentation now. You can get started. You can get started whenever you are ready.
Yes. At first, we would like to introduce ourselves. Myself, Sri Gautam Kalita, and he is my teammate, Mriganga Shekhar Kalita. We are from Sankadev Shishu Vidyaniketan, Teliagaon, Mathuranagar, Nagaon, Assam, India. Next slide, please. Next slide.
Next slide, please.
Next slide, please. This is our contents, project location, our team, aim, procedure, before our experiment. This previous slide. Before our experiment, approaches, experiments with chemicals, result from the working model, design of the working model, cost analysis, our future plan, conclusion, and acknowledgements. Next slide, please. Next slide, please. This is our project location in India. Next slide, please. Next slide, please. Our team, Gautam Kalita and Mriganga Shekhar Kalita. Next slide, please. Our aim to rediscover pure drinking water from pond water, to remove the excess chemical elements which we have found. Our process will be effective in earth-based, Mars-based, and lunar-based. Next slide, please. This is our procedure in brief. At first, we find defining the problem, then researching the problem, and then brainstorming, searching one design, building the model, testing the model, and communicating. Next slide, please. This is our water sample before our experiment. The chemicals are turbidity was 24.0, pH value was 10.26, iron was 5.84 milligram per liter, fluoride was 0.51, milligrammes per liter. Hardness was 220.0 milligrammes per liter. Chloride was 75.0 milligrammes per liter. This is our water quality. And next slide please. The water quality on the graph drawing before our experiment. Next slide please. Remarks of the poor quality water. We can see that the water is not for drinking purpose. Neither anybody prefer for drink. Our team built a model to find out pure drinking water from this poor quality water. We describe the model here. Our group meeting and water sample. Next slide please. Approaches. Rediscover pure drinking water by chemical method. Next slide please. Experiment with chemicals. We used many kinds of materials and activated carbon prepared from ash of banana tree, pebbles, stones of Arunachal Pradesh, Kolakar prepared from ash of banana tree, salt, soft sand, rough sand of Swansea River, and lime. Next slide please. Experiment with chemicals. The first is we used filter paper, filter net, pipe, hanger, plastic jug, plate, and burner. Next slide please. Materials and its quantity in the chart. We have used activated carbon 20 mg per liter, pebbles 500 gram per liter, stones 750 gram per liter, salt 5 mg per liter, Kolakar 8 ml per liter, soft sand 250 gram per liter, rough sand 200 gram per liter, and lime 4 mg per liter. Next slide please. Experiment with chemicals, the materials and its quantity on the graph drawing. Next slide please. Result from the working model. Experiment with chemicals. The water quality was turbidity 9.8, pH value is 6.1, iron 0.11 mg per liter, chloride 0.12 mg per liter, hardness 20.0 mg per liter, chloride 4.0 mg per liter. Next slide please. Result from the working model, the water quality on the graph drawing, and you can see that the water was drinking for purpose. And next slide please. Next slide please. Design of the working model. Our system storage tank with Kolakar, then soft sand, activated carbon, rough sand, pebbles, stones, filter paper, lime, salt, filter paper, and then we got the pure drinking water. Next slide please. Design of the working model. The storage tank, and then you can see that the iron, turbidity, hardness, chloride, and chloride remover, and then you can see that the bacteria remover, and then the last water tank is drinking water tank. Next slide please. Design of the working model. Components of the model. Storage tank with polymer, soft sand, activated carbon, rough sand, pebbles, stones, filter paper, and those materials used for iron turbidity, fluoride hardness remove. And then lime, salt, filter paper was used to bacteria remove. Next slide please. Next slide please. About our model. This is the very important thing of the model. Our model should be effective in earth-based, Mars-based, lunar-based. The materials used in this model are applicable for the purification of 1 liter water. We have used this model 4 times and every time we have got the same quality of water. The maximum duration of the working capacity of this model is 25 days. This model has been prepared on the basis of the quality of the water we have used. After making this model, a maximum quantity of 75 liters of water can be used. If the amount of water taken for purification exceeds 1 liter, the materials used in this model must be increased as per the requirement. This water sample was collected from a nearby pond of a factory. Next slide please. Cost analysis. Materials purchase 200 rupees, boulder 50 rupees, chemicals 150 rupees, contingency 50 rupees, and video editing and camera 1100 rupees, and tutor 1550 rupees. Next slide please. Our future plan. We want to recycle the human urine and remove ammonium part from the human urine, and also we want to make a healthy society. We hope everybody can get pure water for drinking. Next slide please. We can see that the difference between before our experiments result from the working model. Before our experiment, the turbidity was 24.0, but result from the working model, turbidity is only 9.8, pH value was 10.26. After our experiment, pH value was only 6.1. Iron was 5.84 mg per liter, but after our experiment, iron was only 0.11 mg per liter. Before our experiment, fluoride was 0.51 mg per liter, but after our experiment, 0.12 mg per liter. Before our experiment, hardness was 220.0 mg per liter, but after our experiment, hardness was 20.0. Before our experiment, fluoride was 75.0. After our experiment, fluoride was 4.0. Next slide please.
This is our conclusion. After our experiment, pH value is only 6.1, which was acceptable, and iron milligram per liter 0.11, which was acceptable. By designing the working model, we could get SS chemicals free the water. Next slide please. Next slide please. This is our acknowledgement. This project is the fruit of the labor of more than a single person. We still being learners. would have been directionless without the guidance, advice and cooperation of the people whose names are cited below. We extend our heartiest gratefulness for their immense contribution. Next slide, please. Acknowledgement. At first, Dharmadev Brahmachari, which was principal of Shankardev Shishu Vidyaniketan. Next, Kumud Bora, PhD in Indian government. Manajoti Das, English teacher of Concept Junior College, Nagaon. SSEAP, Arjavata Science Center, and Dr. Ashwinta Narayan Bajbura, Professor of North Dakota State University. Thank you.
In Nagaon.
We have a question.
Okay, you have a question? Go ahead. Yeah.
We were wondering, what is the banana ash used for? I think it was
Kolakar. Very good, yeah. Okay, I think question from here, from West Fargo STEM Center. Question is, why Kolakar was used? Why how do you make it and why did you use it? Very good question.
Yes. We use kolakar, and kolakar was prepared from ash of banana tree. Which part of that? Yes, and আমি কলাখাৰটো কল গছৰ বাকলিৰ পৰা তৈয়াৰ কৰিছো আৰু এইটো pH ভেলুটো কমাবৰ কাৰণে আমি এইটো ইউজ কৰিছো.
I'll translate it for you. Okay. I can translate it for him. So, go ahead. Sorry. Go ahead.
Actually, they are using a particular species of banana that is locally called as bean corn, and that variety is basically used usually for preparation of this alkali. And the stem part of the banana is dried and burnt, and as is expected. And this is usually commonly used traditionally in the Assamese society for cleaning of the cloth and washing hair. At the same time, some part of is extraction for food as a food material for boiling of the different foods. From that practices actually they got that.
Okay. Just to add to the answer, that kolakar is a part of, basically they burn the part of a banana tree, and they can burn the banana root also, depending upon what you extract. The alkalinity is high or low. They typically use it for washing clothes and all, so because it is a soda, so that is alkaline. It's a natural product basically, so that's how they use it to raise the pH. Did I answer the question? Okay, very good question. Any other question?
I have a question.
Sure.
Will the water not be saline after the whole process, or you have used salt? And what measure have you taken to remove salt from water? I'm repeating the question. Will the water not be saline after the whole process, or you have used salt?
Okay, the question is, will your water become saline? That is, will it have a lot of salt after the whole treatment process? So what measures have you taken to remove salt from your water?
Yes. Use salt for the bacteria remove, and also lime to bacteria remove, and end of the working on the bacteria remover, and those who use the salt and lime to remove the bacteria.
Actually, my question was, will the water not be saline? What measure have you taken to remove salt from water? Have you taken any measure to remove salt?
Yes, salt, the water, use salt and lime to remove the bacteria. মানে সলটোৰ আমি নিমখটো ইউজ কৰিছো লগতে চূণটো ইউজ কৰিছো কাৰণ এই নিমখীয়া গুণটো কাটিবৰ বাবে আমি চূণটো ব্যৱহাৰ কৰা হৈছে যাতে ইয়াৰ পানীখিনি নিমখীয়া গুণটো নাইকিয়া কৰে আৰু লগতে বেক্টেৰিয়াখিনি ৰিমুভ কৰিব পাৰে
আৰু নিমখটো কেৱল 5 মিলিগ্ৰাম পাৰ লিটাৰ ব্যৱহাৰ কৰিছে বহুত কম পৰিমাণে ব্যৱহাৰ কৰিছে সেইবাবে ইয়াৰ প্ৰজেক্টটোৰ ওপৰত ইয়াৰ বিশেষ প্ৰভাৱ নপৰে
Acha, answer to the question is they have used a very less amount of salt, so that should not affect. Just to add to the answer to the question, I mean salt removal is a major problem from water. So typically if people go for reverse osmosis or similar type of technique. So I think that's a very good question and there are a lot of challenges and a lot of opportunities for further research to do on this one, how to remove salt from water. Very good question. Any other question?
That question from this audience.
Okay, go ahead.
The question is, you guys said you use the activated carbon. We have a question here. Is there any negative effect to the activated carbon in the water? And what is the importance of the activated carbon?
Okay. Would you mind repeating that question one more time?
Yeah, the question is, does the activated carbon have any negative effects on the water? Also, what is the importance of the activated carbon?
Okay. So what is the importance of this activated carbon that you use? And why did you use the activated carbon? That's the question basically.
Activated carbon to use কৰা হৈছে pH level কমাবৰ কাৰণে আৰু এমোনিয়াৰ পৰিমাণটো কমাবৰ কাৰণে এই কাৰণে activated carbon to use কৰা হৈছে
So the answer is ammonia being used to take care of activated carbon is being used to take care of ammonia.
Yes. And also pH value. And decrease pH value.
Okay, and a pH, you think pH value will be changed because of activated carbon?
Okay, that answers your question.
Any other question? Oh. Okay, thank you. This is a very good presentation by Team Nogao. Now we have a team from US presenting. Team from Wisconsin will present now. Before they present, we'll show their video. Can everybody mute their microphones, please? Except Team Wisconsin. Please mute your microphones except Team Wisconsin. Thank you. So, Team Wisconsin has done this project as a part of their contest for NASA. So they have designed this system for NASA contest called it is a water management project for outer space. So they have won the first place in the country in designing so. So I will ask them, they have a video taken at NASA for you to see. So we'll play the video first and we'll go for the presentation after that. Thanks.
Astronauts must recycle water to live and work in space. Middle school students nationwide design recycling systems for NASA competition. This is the winning team.
We are Team Aqua de Vida from Hudson, Wisconsin. Woo! I'm Julia. I'm Brianna. Amy. Dave. Caitlin.
Okay. So you're almost ready to start your presentation. This was the video of their visit to NASA at Florida. Okay, well, whenever you want to start, you can start your presentation now.
All right, thank you. So this is our NASA Water Purification Challenge. I'm Amy Larson.
I'm Caitlin Asmus. I'm Brianna Haig. I'm Abe Whalen.
And Julia Van Allen unfortunately could not be with us today, but this is, we're from Hudson Middle School. Okay, so our challenge was to design a sustainable, next slide. Okay, so our challenge was to make a sustainable water recycling system, which means once you set it up, it should run for as long as we need it to. Next slide. So our problem was, how can we recycle and purify wastewater on the moon? Our hypothesis is, if we recreate a naturally occurring water purification system on Earth, then it should, we should be able to recycle wastewater on the moon as well. Next slide. Our wastewater recipe, so how we made the fake wastewater. It has ammonia, baking soda, table salt, vinegar, shampoo, and of course water in it. It was too dangerous to, of course, use real wastewater. Next slide. Our inspiration for this project came from a NASA video that we watched in class. Most parts of our project are already proven methods of water purification that we researched. So sand and gravel filters, charcoal filters, algae filters, and distillation. Next slide. We each had to have research specialties to make our research more effective. Caitlin became the algae pond biofilter specialist. Bree decided to research algae. I became the distillation authority. Julia became the activated charcoal filter consultant. And Maeve chose the title of Lunar Living Conditions and Space Cost Analysis Expert. Next slide.
The nitrogen cycle is an important part of our project as it rids the wastewater of ammonia. And in the diagram, it shows that ammonia is broken down into nitrites, and the nitrites are broken down to nitrates in the nitrogen cycle. Next slide, please. These are some pictures of us building our project. We used a cheese balls container for our algae filter. And we used a lot of recycled material in other parts of our system. Next slide, please. Step 1A of our project is first, the wastewater enters our water purification system through a sand gravel filter to begin the process of removing the shampoo, baking soda, and any large particles in the wastewater. Next slide, please. Step 1B. Next, the wastewater passes through the carbon filter. This removes any last traces of shampoo and baking soda. This is achieved by the water passing through the many small pores in the surface of the activated charcoal. Next slide, please. You may be wondering, what do you do when the activated charcoal becomes inactive? We considered this problem and found the following solution. If you have a set or two or more of activated charcoal filters, then you could swap one filter in while the other ones heat, dry, and therefore reactivate. Next slide, please.
Okay, so step 2A. The next step in our system is an algae pond biofilter.
This is comprised of a tank into which the wastewater flows from the bottom up. This tank contains different types of bacteria, which break down the ammonia into nitrites, and then into nitrates, which are absorbed by algae. Next slide. We use many different components in our algae pond biofilter. Lava rocks were used because they are very porous and let water seep through. Sand was used because it creates an ideal habitat for microorganisms. Next slide. Also in this tank are several different types of algae, including spirulina, which is edible. The algae absorbs the nitrates that are currently in the water. The algae also will help scrub the air by removing carbon dioxide and releasing oxygen. According to Caitlin, the authority in this area, once the wastewater enters the algae pond biofilter, it takes 24 hours before the wastewater is ready to proceed through the system. Next slide. Step 2B. After the algae pond biofilter, we filter the water once more through an activated charcoal filter to remove algae from the wastewater stream. Next slide. Step 3A. Next, the wastewater passes into an Erlenmeyer flask, where the heat is applied to start the distillation process. The water boils and turns into steam. This steam goes into a pipe leading from the flask. Next slide, please. Step 3B. The stream travels through a tube that spirals downward through a board that we drilled holes into, cooling and condensing back into water that is now drinkable. Next slide. Here you can see our entire system. It is built all with recycled materials. Wastewater enters on the right and exits on the left, completely purified. Next slide, please.
Now you see the data that we recorded. The first 3 slides are graphs of the data that we collected in the first 10 days of our experiment. To test the levels of pollutants and pH in our system, we used QuickDip 5-in-1 test strips and QuickDip ammonia test strips. As you can see, the pH slowly decreased to drinkable levels. The nitrates and nitrites rose and fell just as we expected them to. Next slide, please. This is a graph of the conductivity of our wastewater as our project progressed. We got this information using a vernier conductivity probe. The lower the levels of conductivity, the better. Next slide, please. This is a graph of the alkalinity and ammonia of our project. You can see that they both decreased dramatically. Next slide, please. These are our final results that we took after the wastewater was completely purified. This first graph has the levels of alkalinity, ammonia, and conductivity of our final purified water. As you can see, they are all at optimal levels. Next slide, please. These are the final levels of pH, nitrates, and nitrites. pH is almost exactly at 7, which is perfect, and the nitrates and nitrites are completely gone from the wastewater stream. Next slide, please. Lunar living conditions in space cost analysis. I, Maeve, researched many different aspects of, as my title suggests, lunar living conditions in space cost analysis information, which basically ended up being a miscellaneous category. I found plenty of useful information, from the cost of sending 1 liter of water into space to the new inflatable space habitats. I also worked on figuring out how our system could become automated and how long it would take for our system to become ready to filter water. While much of this information was not useful to our project, we ran across some facts that were beneficial to our project, such as how nitrous ammonias can remove ammonia from water. Next slide, please. Our conclusion. By recreating a naturally occurring biological water purification system found here on Earth, we were able to recycle and purify simulated wastewater. We believe this system could be used on the Moon. We believe that our system works because after our project was finished, all the tests showed that the water was safe to drink. We also showed our belief in this statement by drinking the final water. Next slide, please. Here you can see a collage of us working on our project. over the course of several months. Next slide, please. Thank you for the opportunity from Maeve,
Bree, Caitlin,
And Amy.
and Julia, who is not able to make it.
So now you can unmute your microphones, and if you have questions, Team Wisconsin.
I have a question.
Sure.
Is making safe drinking water an objective of your project? Is making the safe drinking water an objective of your project?
Yes, it was.
So can you follow it
Then,
up?
there will be no minerals left after distillation of the water. What did you do for that?
I think that
There will be no minerals left in the
yeah.
there will
Can
be
I-
no minerals left in the water after its distillation.
And the question was, you have opted for a distillation process. After distillation, there will be no minerals left in water. So it is. Will you still drink it? I think I just added a part to it. That one.
Yes, after the distillation process, there are none of the materials left over.
No, I think the question was, you are basically creating demineralized water. You don't have any mineral left in the water. So will the astronauts be okay drinking the demineralized water?
They do add things to the water afterwards that we didn't do in the process. So, yeah.
Our objective was simply to purify the water so that it could become usable. Our objective was slightly different from ours, as we were supposed to create a system that could be used on the moon, and NASA would add any minerals or nutrients deficient from the water afterwards.
And I think that's a very good answer. I think in what they do in spacecraft or lunar settlement, they'll be trying to purify the water. Then of course you can add on additional stuff to it, minerals that is needed. So that was the whole purpose. Otherwise, it's so difficult to get pure water. Yes, go ahead.
So making safe drinking water was not their objective.
No, it was making safe water was their objective, and finally, because it is just the addition of chemicals to it. So that's what many times we do. If you do not have proper water, then you just prepare distilled water and add chemicals to it, which becomes a regular water after that. So you know that outer space is a very difficult space to live. So even if you can get distilled water, that's a remarkable achievement.
Thank you.
Any other question? I got a quick question for Wisconsin. So what is your plan after this? So what are you guys doing nowadays on water? Are you doing any project on water?
We are thinking about it, but we are not currently doing anything new at this point. Is there anything else you need to know?
Oh no, yeah, definitely. We may have some opportunities for you to work, possibly. We'll find out some opportunities and let Chris know about it.
Thank you.
Any other question? Okay, thank you very much. Okay, now can everybody else except Team Nagaon mute their microphones? Team Nagaon, you need your microphone out there because you will be speaking now. So now we have a presentation again from Nagaon. This is the Nagaon Bengali Girls High School. So will you be presenting in Bengali? Are you presenting in Bengali, right? Nagaon, can you hear us? Will you present in Bengali? Or English? Okay, that's great. Okay, great. So you're presenting in English or Bengali?
English.
Okay, good. Okay. Now we'll start with your song that one of you have sung. So we'll start with that one, then we'll go for the presentation. Thank you. That is a song about water. So water as a major component for sustenance of life. So we are going to go with your presentation. Whenever you are ready, you can start your presentation.
Yes. We are the student of Nagaon Bengali Girls High School, Nagaon, Assam, India. Our project title is Iron Removal from Water Collected from Tubewell Using Charcoal. Next slide, please. Next slide, please. Our focal theme is WateRediscover. Next slide, please. Our project team is Shabna Meghali, Monami Mojumdar, Jayati Pal, Noina Bhattacharya, Boishakhi Datta, Ishani Das, Pranita Bhattacharya, Supriya Sarkar, Anupa Pal, Jayashree Saha. Next slide, please. Next slide, please. Background of the study. Iron content in groundwater is a recurrent problem. Excessive iron content in groundwater gives rise to health. Previous slide, please. Excessive iron content in groundwater gives rise to health and sanitation problem. Causes problem for people depend on groundwater source. Next slide, please. Next slide, please. This is the rough sketch map of the study area. Next slide, please. Next slide, please. Our aims and objective. The following are the aims and objectives of the study. Number 1, observation of suitable of different types of charcoal for iron removal from water collected from tubewells. Number B, observation of capacity of filters made from charcoal from trees to remove iron content from water collected from tubewells and removal of additional iron content in tubewell water involving small cost. Number C, renovation of traditional filters along with improvement of their qualities. Number D, explore means to make the manufacture of charcoal-based iron removal filters for tube wells economically viable. Next slide, please. Our need statement is the study topic was selected based on the following aspects. Number A, excessive iron content in water collected from most tube wells of Nagaon district. Number B, consumption of water with excess iron content is harmful for human health. Number C, fuel odor of water collected from the tube wells from most part of Nagaon town due to excessive iron content. Number D, color of cloths washed with water from such tube wells turn reddish due to iron content in the water. Number E, common people face various problems when they want to test the water of their tube wells in the District Public Health Engineering (PHE) department. Number F, huge cost in purchase of filters to remove iron from tube well water. Number G, locally made charcoal-based filters are idle iron removal tools from tube well water. Number H, challenge is to make manufacture of charcoal-based iron filters cost-effective and acceptable among the masses. Next slide, please. Our work plan is preparatory stage, orientation of students by teachers, formation of project team, discuss in project topic, finalization of topic. Previous slide, please. Finalization of topic, selection of study area, finalization of work plan and methodology. Project execution stage, data collection and data analysis, identification and collection tube well water with the iron content, testing of collected water samples in the local PHE department, preparation of charcoal from different tree species, filtration of water with iron content in charcoal-based filters, laboratory testing of water filtered with charcoal-based filters, preparation of cost-effective charcoal-based water filters, popularization of charcoal-based water filters among the masses, report writing stage, compilation work, preparation of draft report, finalization of draft report, final report preparation. Next slide, please. Next slide, please. Our methodology. The following methodologies were adopted for the execution of the project. Number 1, methodology for household selection and water sample test. Number A, both survey and experiment based methods. Number B, selection of households with tube wells through random sampling method. Number C, out of a total of 100 households with tube wells, 10 samples were selected on the basis user's choice. Number D, collection of water samples from the tube wells for laboratory tests. Instruction of the PHE department were collected and followed while collection of water samples. Number E, labeling of water sample were done as per the household number and name of locality. Number F, laboratory test of water sample at the district PHE department with spectrophotometer instrument. Next slide, please. Next. Number 2, methodology for test of charcoals as filter for iron content in water. Number A, collection of 5 different types of wood sample from 5 types of tree. 1, jute stem, botanical name Corporus capsularis. Number 2, Barney series, botanical name Algebia lucida. Number 3, bamboo, botanical name Melcona basifera. Number 4, jackfruit, botanical name Artocarpus heterophyllus. Number 5, teak, botanical name Tectona grandis. Number B, burn the wood samples and preparation of charcoal from them. Number C, these 5 different types of charcoal were used to prepare 5 different types of filters. Number D, basis of selection of the tree species, hardwood trees, locally available, plantful and makes good charcoal. These trees are used by our school for preparation of midday meals. This photo is different types of charcoal used in the experiment. Next slide, please. This is the photo of charcoal made through burning in chula in. Next slide, please. Chula in school where midday meal is prepared. Next slide, please. Number 3, methodology for preparation of charcoal-based water filters and test of the filters. Number A, collection of 15 half-liter mineral water bottle, 3 each for 5 different types of charcoal. Number B, cutting them into half. Number C, arrangement of coal, sand, sandstone in the bottles in respective. A, sand 2.5 gram, B, sandstone 2.5 gram, C, charcoal 5 types, D, water with iron content 1 liter. Number D, test of the water filters by pouring water collected from tube wells with apparently high iron content 1.19 mg per liter into all the filters. Number E, filtered water is collected in appropriately labeled bottles. Number F, the bottle were taken to the PHE department laboratory for testing of iron content. Next slide, please. Next slide, please. This is the treatment of charcoal-based iron removal water filtered from 5 different types of charcoal. Next slide, please. Next slide, please. Number 4, a procedure for the test of water samples with spectrophotometer in the district PHE department laboratory. Number A, water samples collected is poured into test tubes taking 5 mg of collected water from every water bottle, numbered serially. Number B, laboratory test in the PHE department is done using the spectrophotometer instrument. Number C, laboratory tested can be done with irometer also. Similar tests can also be done using chemical reagent solution, though it consumes more time. This photo is spectrophotometer used in the experiment. Next slide, please. Data analysis and findings. Number 1. Spectrophotometer analysis of collected water samples show that iron content of number 4 water bottle sourced from the tube well in the campus of our school, Nagaon Bengali Girls High School, Bengalipatti, Nagaon, was the highest 1.19 mg per liter. The acceptable range of iron content in water for human consumption is 0.3 mg per liter. Next slide, please. Next slide, please. Data analysis and findings. Number 2. Water sample from tube well of our school which had the highest iron content 1.19 mg per liter was used to test the suitability of 5 different types of charcoal for filtration of iron content in groundwater. Official result from the PHE laboratory reveal the following results. Here the red line is acceptable limit of iron content in water for human consumption. Next slide, please. Next slide, please. This is the official spectrophotometer report of water quality test using 5 different charcoal-based iron removal water filter. Next slide, please. Next slide, please. Outcome and conclusion. Number 1. After 15 days, the same charcoal filter which was used 15 days earlier is tested again. Number 2. The results came out to be the same. Number 3. On review of the result of the experiment in the PHE department, half kg of charcoal can be used for filtration for 6 to 7 months easily and smoothly. Number 4. The Barney series Alzibia lucida, which gave the best result in the filtration process, is available locally and naturally. Number 5. Which filter and their manufacture is inexpensive and easily available for the poor. Next slide, please. Outcome and conclusion. Number 1. Charcoal based on charcoal proceed from Barmecides trees, Algipia lucida gave the best result in the experiment. Number 2. At present, the wood source from this tree is used by many schools and households as firewood. The residual charcoal of this tree is not used anywhere and therefore it can be utilized for making low-cost charcoal-based iron removal water filter. Number 3. Further charcoal residue from bamboo, Malcona basifera, jackfruit, Artocarpus heterophyllus and Tectona glandus was also being used for making filters which remove iron from water below the prescribed acceptable limit of 0.3 mg per liter. Number 4. Even charcoal-based filter made from charcoal of jute Corporus capsularis provide result marginally above the acceptable limit. Number 5. Such filters can be ideal substitute for high-cost iron removal water filters and are acceptable among the scientific community. Next slide, please. We acknowledge the guidance of the following peoples with our work. Number 1, Srimati Devidas, Headmistress, Bengali Girls High School. Number 2, Sri Achinto Bejpura, Professor of North Dakota University, USA. Number 3, Srimati Aparna Bhattacharya, Project Guide and Assistant Teacher, Nagaon Bengali Girls High School, Nagaon. Number 4, President, Secretary, Project Coordinator and members of the Society for Socio-Economic Awareness and Environment Protection, CEP, Nagaon. Number 5, Official and Laboratory Assistants, Public Health Engineering Department, Nagaon. Number 6, Official of the National Informatics Center, Nagaon. Thank you all of you. Next slide, please. This is our references. Thank you.
One slide there. Thank you. So, everybody can unmute their microphones now. And if, do you have any questions? If you have questions as well. Yeah. Team Tezpur, you have any question?
No, sir.
Okay. Wisconsin, do you have any question? Yeah, go ahead.
Yes. Wisconsin has a question.
Sure.
What was the process of making your activated charcoal?
Okay. Now question is, how do you make your circles? Circle bila kene kya bunwa tumaloge? You can answer in Bengali. I'll translate it for you. Can you repeat your answer one more time?
যেখানে আমাদের মিড ডে মিল তৈরি করা হয় সেখানে চুলায় আগুনে আমাদের কয়লা প্রস্তুত করা হয়েছে।
আচ্ছা, I think that I just translated it for you. They did it at their school kitchen. They got some wood chips, wood lumbers, and burned them in the school kitchen. So they have a midday meal program in school. The food is prepared in the school itself, like our, the dining services in US. Of course, we prepare centrally. Each school have their own kitchen in India. So they just use their prepared circle there itself. Not exactly activated carbon. These are circles.
All right.
Other questions? Other questions? Does Team Saudi Arabia has any question?
No, sir. We don't have any questions.
So I got a quick question for you. Now, your design, with your new design, how much is going to cost? For say I have a tube well, so how much it will cost me to have a iron removal system installed?
$300. 300.
300 rupees?
Yes.
Okay, 300 rupees means about $6 or $7. So that's very, very, very less expensive. Okay. Any other question? Thank you. Now at this time, I request all of you to mute your microphone except Team Saudi Arabia. So now we'll present the video prepared by Team Saudi Arabia, then we'll go for your presentation. We'll present the video now. Video in Saudi Arabia. In 30 I apologize. Thank you for everybody rising up. This is a national anthem. Now we are playing the video for Saudi Arabia.
أرفع بهامي لكم يا فخر هذا البلد، يا أملنا كلكم بنت وولد. أرفع بهامي لكم يا فخر هذا البلد، يا أملنا كلكم بنت وولد. انجز يا ولد أرضك وداوم في العمل، ازرع اصنع في بلادك دام في نبضك أمل. انجز يا ولد أرضك وداوم في العمل، ازرع اصنع في بلادك دام في نبضك أمل. في ثباتك معنا شكرا والعفو، كفو انت كفو. لا سما تمطر ذهب، لا بحر يهديك مال، راحتك بعد التعب والتحدي راس مال. لا سما تمطر ذهب، لا بحر يهديك مال، راحتك بعد التعب والتحدي راس مال. وانت بين الناس تفخر، هذا حق.
We'll go back to the national anthem one more time. Okay. I apologize because I didn't announce the national anthem. We'll go back to the national anthem one more time. Can I request all of you to rise for the national anthem of Saudi Arabia? Can everybody rise? Everybody please rise for the national anthem of Saudi Arabia. Thank you very much. Now we'll go for the presentation by Team Saudi Arabia. Whenever you are ready.
Okay, we are ready. بسم الله الرحمن الرحيم، والصلاة والسلام على خاتم الأنبياء والمرسلين. أما بعد.
In the name of Allah, the most merciful. Peace and blessing be upon the messenger of Allah. And then
نرحب بكم في عرضنا.
we welcome you in our presentation.
Next slide please. هؤلاء هم أعضاء الفريق.
These are team members.
أحمد الجهني.
أحمد الجهني.
معاذ المالح. أسامة العبثاني. زياد الثقفي. إياد بابطين. محمد صباغ. Next. عبد الجليل مرشد. عبد الرحمن هاني. بشير قسان. محمد رضا. Next slide please. معلومات بسيطة عن المملكة العربية السعودية.
Some normal information about Saudi Arabia.
المملكة العربية السعودية تقع في قارة آسيا.
Our country is Asia.
وعاصمتها الرياض.
And its capital city is Riyadh.
ويبلغ عدد السكان 29 مليون.
The population in Saudi Arabia is 26 million.
ولغتها العربية.
And our language is Arabic.
Next slide please. كما ترون في هذه الخريطة يوجد لدينا الدول من حيث قلة الجهد من المياه.
As you can see in this map, it shows the freshwater scarcity source, and as you can see, our country is under this, which indicates that it has this problem with water. Next slide, please.
أهداف البحث.
Research objectives.
فهم مشكلة المياه في المملكة العربية السعودية.
Understand the water problem in Saudi Arabia.
إيجاد الحلول لها.
Suggest solutions.
تصميم الاختراعات لهذه الحلول.
Design and evaluate the solutions. Next slide, please.
فهم المشكلة.
Understand the problems.
من حيث القراءة والاطلاع.
We should start first with the literature review.
زيارة الشركات المتخصصة في معالجة المياه ومقابلة المتخصصين.
Also, the students did a visit to the water facilities and interact with the specialties. Next slide, please.
وكما ترون هذه زيارتنا إلى شركة لمعالجة المياه تسمى مرافق.
As you can see in the slides, these are some pictures from the visit to Marafiq, which is the treatment plant.
كما ترون تنقسم معالجة المياه إلى قسمين.
As you can see, the water treatment divided into two sections.
المعالجة للبيوت.
The first one is the treat for houses.
المعالجة للمصانع.
And the treatment for industries.
وتعتبر معالجة المصانع أنقى وأدقى.
And the factory treatment are better and purer. Next slide, please.
مصادر المياه في المملكة.
Water resources in Saudi Arabia.
واحد مياه الأمطار.
First of all, rain.
وهناك إحصائية تقول 59 ملم في السنة 80 منها تتبخر.
And there are some studies shows that the precipitation average in Saudi Arabia is 59 millimeter per year and 80% evaporates.
اثنين المياه الجوفية وهناك إحصائية تقول 30 منها استخدم.
Then there's the groundwater and there's a research says that 30% are being used.
ثلاثة مياه التحلية.
Then the desalination water.
وهناك إحصائية تقول 72% استخدم في سقي المزارع واستخدام في تنظيف البيوت.
There are some research shows that the 150 million centimeter cube and 70% of the total water supply. Next slide, please.
استهلاك الفرد اليومي.
Household consumption.
واحد 230 لتر في اليوم للفرد الواحد.
230 liter per day for a person.
وهي واحدة من إحدى الإحصائيات العالية في العالم.
And it's considered as one of the highest consumption rates in the world. Next please.
الحلول.
Solutions.
ترشيد استخدام المياه.
Reduce consumption.
وهو عن طريق منبه الصوت للصنبور.
And by creating a new alarm system which is called the water tap alarm.
إيجاد مصادر المياه الجديدة.
Create a new water resource.
من حيث استخدام مياه الأمطار.
By using the rainwater harvesting. Next slide, please.
منبه المياه المزعج.
Water tap alarm.
الأدوات.
Tools.
أسلاك.
Cables.
بطاريات.
Batteries.
مروحة.
Fan. And hydrant electric.
مكبر صوت.
Sound device.
ألارم.
Lamp.
ولوحة وقاعدة كهربائية.
Electric connection board. Next slide, please.
صنع الدائرة الكهربائية.
Procedure. First of all, we install the electric circuit.
ثانيا وصلها في صنبور المياه من حيث الأسلاك.
Connect the electric cables in the hydrant.
عندما يفتح الصنبور تغلق الدائرة الكهربائية.
The hydrant rotation leads to the connection of the electric circuit.
وتدور المروحة وتصدر أصوات مزعجة.
And should establish a light and sounds warning as water passes through. Next slide, please.
الاستفادة من مياه الأمطار.
Rainwater harvesting.
الأدوات.
Tools.
فلين كبير.
Foam.
بيت سطحه مستوي.
A house.
ماطور يضخ الماء إلى الأعلى.
Pump.
خزان.
Storage.
يسقط المطر فوق البيت.
The water will fall above the roof. The house.
فينزل الماء إلى الخزان.
The water will go on the storage.
وينتقل إلى الفلتر بالتصفية.
Then it will go to filterize it.
ويصل إلى الماطور.
Then it will go to the pump.
ويعود ماء صافي.
And then pump it out to all the house. Next slide.
الأعمال المستقبلية.
Future work.
استعمال المنبه في شلالات المدارس ومقارنة بينهما قبل وبعد.
They can install the alarm device in the school and measure the water consumption before and after.
تصميم سطح مستقيم وكبير لحصد المياه.
Design a large-scale roof water harvesting project.
كمان التوعية من أجل استخدام المياه.
And finally, we will raise the awareness of water problem.
الخاتمة.
Conclusions.
تم تصميم واختبار منبه المياه المزعج في المختبر.
Water tap alarm was designed and tested in the lab.
حاصد مياه الأمطار لقد بني واستعمل في المختبر.
Rainwater harvesting model was built in the lab and tested.
كما يمكننا استعمال الشبكة الإلكترونية في توعية الناس للترشيد من استخدام المياه.
Also, in our time, we should use the social network and to raise the awareness of the people. Next slide, please.
Acknowledgement. Abdullah bin Masud al-Juhani, Abdul Rabbu al-Zahrani, Khalid al-Shihri, Yahya al-Malih. Follow us on Facebook and YouTube. Next slide, please. Follow us on Facebook and YouTube and our application on Android. Well, thank you for this amazing conference. We wish everyone the best of luck.
Thank you.
Now, it's open for questions now. Maybe I got a quick question. So how does your alarm work and how much does it cost you?
Actually, it actually costs around $5.
Okay. Okay.
And they taste it in the lab.
Okay.
So it's good.
Okay, thank you. Yeah. Any other question? Do you have any question? Wisconsin, do you have any question? No, okay. Nagao, do you have any question? So do you, I got another question for Saudi Arabia. Do you plan to join this WateRediscover next year as well?
Yeah, actually the first time was so excited, so we are planning to join this conference again next year. And thank you for giving us the opportunities to join you guys. Thank you very much.
Sure, thank you. Yeah, that's good that you joined this time. You know, it is very good. You know, it is very, looks like you have a very good school, and a lot of school teachers are very interested, principal is interested, so that's a very good sign.
Yeah, that's all under this amazing conference. So the thanks goes for you and your team.
Oh, thank you. Yeah. Well, now thank you again. I know I'm so happy that we are so much ahead of time. You know, we plan it in such a way so that we are prepared for the longest time. But I knew from the beginning that we will not be spending 4 hours. But we have the last presentation now of the conference today. And we'll have another follow-up conference on July 10th. That will be with a team in Uganda. So now we have a presentation from West Fargo STEM Center, West Fargo Science, Technology, Engineering and Mathematics Middle School. So we have 3 students here, and they are using a new software. They are not using PowerPoint. They are using a different software. They will talk about that a little bit also. You can talk about the software a little bit before you start. So they are using a different softwares, and video is built up into that. So it will take a few minutes to install that one, just because it is not a regular program. So they will just get it installed. Just be patient for a few minutes. Then we'll get started. And in the meantime, if you have more questions to any other group, you can asking questions.
Cynthia, now had a question, I think, for the previous group.
Okay. Yeah. Do you have questions for previous groups? Maybe Saudi Arabia now. You may have a question for other groups now. You can ask in Arabic, and then somebody else will translate it for you.
Okay, Doctor, we have a question here.
Sure, go ahead.
Yeah, basically, this question is for you.
Give me 1 minute. Can everybody else mute their microphones for the time being?
Can you hear me, Doctor?
Yeah, now good. Go ahead.
Yeah, the question is for you. Based on the previous experiments, which elements that you think can purify the water the most? I mean, some teams use the charcoals and others use the aluminum, and some of them use the salt.
Sure.
So which one do you think that can purify the most?
I think most important thing here, what most of the team are conveying here, is the sustainability of water treatment plants. I think to be sustainable, you have to use local resources. So a team in India cannot depend on somebody produced in the US, or people in US or in Saudi Arabia cannot depend something being produced in India. So I think local sustainable materials are very important. Also, as you can see in most of the presentations, people are using traditional materials, also natural energy and natural resources, plants and etc. So that's the indicator. I will not really pinpoint this is the best technology or the other. I think all technologies are good and has to be tested. And based on that, we should be able to evaluate.
Thank you, Doctor.
Okay, sure. Any other question? Yeah. Go ahead. What পরিধানের কোড প্রবলেম আছে ইমান বাংলাদেশ আর ইউএস নে কোড Saudi Arabia. Okay, I think there's a question for Saudi Arabia. So what is the what is the water problem there? What sort of contaminant do you see in waters in Saudi Arabia?
Actually, we have a lack of the groundwater and then we are depending on the desalination water, which is depends on the oil. So once we run out of oil, we're gonna run out of water. So that's the real problem.
Okay. I think Saudi Arabia and those countries in the Middle East, they have a lot of water scarcity issues, but they're fortunate that because they have the resources from their oil dollars, and they can always go for desalination, other sophisticated treatment plants. So that's right now that's what they're doing, and they're doing desalination a lot. So you guys are ready almost. You ready? Okay.
They're not going to have a video. The video's not opening, but they have.
Okay, that's fine. Okay, so we'll start with the presentation, right? Yeah, okay. Okay. Now West Fargo is going to make their presentation. I think their video is not working for some reason, so we'll make sure that I send the video to you in a different link, so that all of you will get the video to see later on. I'll email it to your facilitator or your mentor later on. Now I give the ask the West Fargo STEM Center to make their presentation. Go ahead.
This is our WateRediscover project. I'm Jaden Bowler, this is Allison Alt, and this is Amelia Asa, and we're 7th graders from the STEM Center in West Fargo, North Dakota.
We're located in the U.S. in the northern half in North Dakota, and we are in West Fargo.
North Dakota has very flat lands with fields, and we have harsh winters as seen in the bottom left-hand corner. We are also very windy, as seen in the middle picture, and that's our state flag in the bottom right-hand corner.
North Dakota has many water problems like flooding, so when it floods, it picks up any contaminants that might be on the ground. It brings it back into our water supply, which isn't good. We also have agricultural runoff, which collects fertilizers and pesticides in the water. And of course, we have fracking water, which has a ton of chemicals inside of it, as well as sedimentation.
We will be focusing on fracking in North Dakota, and fracking is located in the western half of North Dakota, and there's currently 6,000 wells, and there's room for 30,000 to 45,000 wells, and this map is a map of the fracking, when fracking is located. It's located in western half of North Dakota, and also in Canada and Montana.
Fracking takes a lot of water and wastes it. So each time a well is fracked, it uses about 4 million gallons of water, and one well can be fracked once per day. There's about 6,000 wells, as Amelia mentioned before, in North Dakota, so that means they use about 24 billion gallons of water in one day.
What is fracking? So for this part, we have a well at the top, and it comes down through a pipe and goes to the side. On the pipe part, it is supposed to be protected by a cement barrier, but it doesn't always work because of the low maintenance of it. There's a lot of water is used to this to carry down the fracking fluid to break up the rock, and also to bring up the oil that's collected underneath it. And that's just a brief definition of what fracking is.
And fracking can cause drinking water contamination, and fracking fluid is used to pull up oil, as previously mentioned, and the cement barrier isn't always maintained enough, and it can wear away over time, and these leaks can go into city water, and this can contaminate water drinking by humans.
Excellent. We've read many news articles from out in western North Dakota where people have complained that their water is a yellowy color, as shown in the sink there. The yellow color of the water is because of the large amounts of sedimentation or sand and dirt, and the chemicals in the fracking fluid.
From this map, you can see that fracking has been used all over the world, but it is mainly used in the southern hemisphere, so in Europe, and there's also different spots in the United States that use it as well.
we've come up with a solution for this contaminated fracking water. And within the process of fracking, a lot of water is used. And our solution focuses on multiple filtering steps to remove foreign main chemicals in fracking fluid. And fracking fluid substances that are commonly found are sand, copper, and acids.
We conducted 4 main batch studies, which is just basically taking individual contaminants and trying to take them out. We only did it one at a time because we wanted to change only one variable at a time.
The first batch study that we did was sedimentation, which is gravel and sand, and we decided to either use a screen or let it settle out. Our chosen idea that we picked was to let it settle out because the gravity will let it sit at the bottom and it's easier to take out and clean, whether instead of using the screen, which would get clogged if we put too much, and we also had to use a very fine screen to actually catch all the sand so it would not flow through the water.
And for our sedimentation testing, it took around 30 minutes for the sediment to settle at the bottom of the container. And for our percentages, we took 10% solution, and it took 10 minutes for this to settle out. And we also took 20% solution, and this is 25 minutes for it to settle out. And we also took 30% solution, which took 35 minutes to settle out. And we use these different solutions because 20% solution is the amount of sand in fracking fluid.
We also took out metals out of the dirty water. In the fracking fluid, there's many metals in there. We chose just to take out copper, but if this were a real filtration system, there would be many more metals that you would have to take out using different methods. About 0.5% of the fracking fluid solution is made up of chemicals, but it doesn't seem like very much, but they can be very dangerous when in water.
So for our brainstorming ideas for the metal, we decided that we might do seashells using calcium carbonate and precipitation. So the seashells brainstorm was to crush up an amount of seashells and run it through a filter paper. But the only reason why it did not work for this one was that there was too much, like a high amount of copper in the water, and then we needed something to activate the carbonate that's actually in the seashells.
We use precipitation to take out the hard metal from the water, and precipitation, it means to form a solid between two substances, and in this case we changed the pH to help form this solid. And this graph down here is a graph of how precipitation is used for pH.
So on that pH scale, we increase the pH to form a solid we use sodium hydroxide, which is a high pH liquid, and we put it into the copper solution, and it settled out the copper on the bottom.
For balancing the pH levels, we had to add orange juice, add lemon juice, and hydrochloric acid. We added 0.5 milliliters of lemon juice to every 5 milliliters of recovered copper-free water. And so when adding the lemon juice, we decided to do that because it was more of a natural idea, and it also balanced it to perfect at about 6 of the level pH.
And for balancing our pH, for orange juice, we used 3 milliliters to every 5 milliliters of water. For hydrochloric acid, we used 0.5 milliliters to every 27 milliliters of water. And for the lemon juice, we used 0.5 milliliters to every 5 milliliters of water. And we used these three substances because they had a high acidity. And we chose lemon juice because it is a natural and easier access. But usually, if a company would use this, they would use hydrochloric acid because you use less of it for water, the amount of water.
After getting all of the other things out, we only have 2 things left in the water to get out to make it reusable for the fracking sites. So the first one that we have to take out is the color and organic contaminants. So this would be where we remove the yellowy tint of water. So we brainstormed 2 ideas. Both of them use carbon. It's just one is mixing the carbon into the water and then filtering it out through filter paper. And the second idea was to pass the water through the carbon. We found mixing the carbon and filtering it out to be a better solution, and the water was clear.
So these are just some examples from what we've taken from our testing. So the before one is the one with all the sedimentation and chemicals in it, and then the after one is what we got out of our testing that we did.
And what is carbon? Carbon is a chemical element, and we use carbon to pass the chemicals by, and this would absorb it, and because of its large surface area.
The last contaminant that we have to take out of the fracking water is salt. We only had 2 brainstorm ideas. We could either use a distillation process or a reverse osmosis. Distillation would be turning the vapor into, or evaporating the water and turning it into a vapor, and then turning it back into solid water just with no salt in it. Then reverse osmosis is like that picture down there. It's applying pressure to push all the salt to one side, and the salt will be on one side and the water will be on the other. And our chosen idea was distillation.
This is just an example of the distillation system that we used. So on the part that kind of looks like a pot is something that warms up the water with the salt in it, and then the vapor from the water rises up into the tube and goes into a smaller tube, while a sink is run and the cold water is on the outside of the smaller tube on the inside. So then the vapor turns back into regular water that's drinkable.
And for our salt testing, we have examples of what we did. And for distilled water, for the weight of the boats we used, and we put boats into an oven, and the boats had water and salt in it, and we would heat that up and see how much salt would be left in it, and this is our data left from it.
These studies are a continuous flow, so we did all of the batch studies combined into one continuous flow, and it gave us our final results.
So these are some of the brainstorm ideas we created. So the one with the boxes and the little tubes coming down from them, this was just a pyramid system, so we could regulate what we were putting in and taking out of the water. This was initially our final design that we chose, and then the bottom one would be a smaller process of doing it. So we'd have different steps, but it'd all be combined into one process of it in that design that we created. So we in the end chose the pyramid one because it was easier to regulate, but the other one was another option that we created.
And our chosen design was to use flow tubes, and we would start at sedimentation and go to copper removal, and the flow tubes would be used to stop the water after it has been entered, and we went from copper removal to pH balancing, and then to the carbon mix, and then to the filter, and then we went to salt removal where we distilled the water.
So the steps of the continuous flow was to, one, get out the sedimentation, and I don't know if you guys will be able to see this, but this is everything combined together. So there's sand sitting down here, and then there's copper and salt up there. And then after we get the sand out, it's just blue water. I don't think you can see that, but And then after that, we settle out the blue. So there's blue, that blue stuff is all the copper down there. And then this is the clear liquid from the top up here. And that clear liquid, we have to balance the pH out for the water to taste better. And this is the water with the lemon juice in it to balance the pH. And then we put carbon in there to remove the organic contaminants, and then we get clear water. And then we distill it after that.
So this is our conclusion, just everything wrapped up of what we've done throughout the whole process.
We found that this filter worked well for the chemicals we were trying to remove, and we did a lot of redesigning to create something that would be able to be used as a filter.
Some things that didn't work so well for us was like if we were to make this a real working system, we didn't brainstorm ideas for other metals to take out, so we might have to use other methods. And the process can also be timely because of the distillation and the settling out, and pretty much everything takes a lot of time. It can also affect climate change, fracking can, but at the same time we're saving water, so.
These are just some of our website sources and our picture sources.
These are our picture sources.
Thank you for watching our presentation. We hope we made you more aware of fracking issues and that we answered all of your questions for now.
Thank you very much. I mean, these are 7th grade students from STEM Center. Maybe what we're going to do, if you can demonstrate your test tube things one more time, what you're saying, and Daniel is going to focus the camera more on you, so you can explain. You have a little louder, maybe, that everybody can hear. Yeah.
Okay.
Go ahead.
So this is the first step. It's everything all together, and you can see there's sand right down here. That's sand, and then this is all the copper and things like that. And this is everything that the sand settled out. It's just copper, salt, and organic contaminants. And then this is, once we added a higher pH, this is the copper settled out down here, that blue stuff. Then we took the clear liquid from up here and put it into here. And so that's just high pH. It's at a pH of about 10. Then we added lemon juice because it's acidic, and that brings down the pH level to a neutral, which is about 6. And then to take out the organic contaminants, we added charcoal. So this is charcoal or carbon. And then we distill it, and you get clear water to reuse.
Thank you. So now, anybody has questions, you can unmute your microphones now.
Excuse me, I have a question. May I ask a question? Okay then. One of your ideas was to mix orange juice, but we found that it gives an odd smell and odor to the solution. So what you have done to remove the odor from the solution?
We did activated carbon because it removes the color and the smell from it, but we used lemon juice, not orange juice. Orange juice was just a brainstorm from ours. We found orange juice not to be acidic enough.
Thank you. Thank you.
Just to add to their presentation, they say during their presentation they said they have to test more metals, but their theory of increasing the pH will work for most of the metals because metals have certain solubility and low pH. But when you raise your pH, metal always become insoluble and they settle out. So this technique should work for most of the metals. I mean, there will be a slight variation of pH. So you have actually standard curve for those, solubility curve. So you can use that You can use that solubility of different metals. And normally in low pH, most metals are soluble. Then when you raise your pH, all metals will settle down. And that's a technique normally used for treatment of such water. Any other questions from other groups?
We have a question.
Sure.
Did you drink the resulting water in the end?
No, we didn't.
Okay, because we were wondering how it tasted.
No, we didn't.
So, I think I hear them. They are offering to send some water to Wisconsin if you want to drink.
That'd be great.
I think your purpose is to not to make drinking water, right? You are not trying to make drinking water. Can you clarify on that point, what you are trying to achieve?
We're trying to reuse the water because since they use 4 million gallons every day, and they just end up they don't reuse the water. So we just want to get it clean enough so that they're able to just reuse it over and over again.
Can salt water be used for fracking?
Possibly, I don't know.
I think with the salt water, what happens, if you have salt already, then they normally will mix some other salts in the fracking water. So the fracking water needs some salt and some oil content in there. So they will be mixing that. If you already have some salt, so you will be able to mix less salt there. So it is desired you don't have salt, but some amount of salt should be okay. But there are US EPA regulations, United States Environmental Protection Agency regulations. What sort of how much pure water you need to have. I don't think they will allow you to inject saline water to the aquifer.
Okay, I have a question.
Sure.
Okay, you have told that you have used activated carbon. So what's the source of that activated carbon?
Can you repeat that question?
Okay, you told that you have used activated carbon, carbon filter. So what's the source of the carbon filter?
Okay, what is the source of your carbon? Where do you get the activated carbon from?
We didn't.
Did you buy it?
Yeah, we just bought it.
You can say that.
We just buy it. We didn't make it or anything.
Activated carbon is typically used for aquariums and all. When you have fish, you use activated carbon there. So if you go to a pet store, you can buy activated carbon. So that is where you got it from? Okay. So you can use that. You can buy it. You can make it or you can buy it. So they decided to buy because that's not their objective of making activated carbon. Good question.
Thank you.
Sir, I have a question. Sir?
Yeah.
I have a question.
Go ahead.
Sir, can you protector of opening of the requires that waste fiber বানপানী হয় তেওঁলোকৰ এই মডেলটোৱে কি বানপানী হোৱা সময়ত খোৱা পানী যদি অভাৱ হয় তাত তেওঁলোকৰ কি মডেলটোৱে আৰু সহায় কৰিব পাৰিব নেকি বাৰু?
Okay. Let me translate the question to English. So they were asking, you talked about flood in Fargo, they thought West Fargo also have flood, but Fargo have flood definitely. It is like Assam, same thing. So I am from Assam. For me, flood is not new. So this sort of we get flood. By the way, I mean those people who are from Assam, they're from the highest rainfall zone in the world. They get 350 to 500 inches of rain every year. So that's the rainfall you have. Now the question was, can you use your technique to purify water if there is a major flood? For supplying water to drinking water to people. You can answer whatever you feel like.
We'd have to adjust to the things in the flood.
Sure. I think the question was, I think they were doing, just to, if I can answer for them, I think they're looking at fracking water. Fracking is used for extracting oil from cells. It is not a regular, like I know in maybe Saudi Arabia, India, in Assam also you have oil, but that oil is easily available. This oil they extract in North Dakota and Ohio, those oil is bound to the soil out there, soil and sand. So they need a separate technique. They have to basically remove the oil first from the soil and the sand. then they can extract it. That's why they inject some chemicals, mix with water. That is the fracking water. But once the water comes out, they just simply throw away. Throw away means that they have to dispose it. So that's what they're trying to solve. They're trying to overcome the problem of throwing away fracking water, reuse them. So the purpose. I don't think that this same technique can be used for drinking water purposes. And their purpose was not drinking. Am I right? Did I answer it right?
Yeah.
Okay. Okay.
Thank you.
Any other question?
قطرة الأرض يوم الندى مكتوب؟ نسميه نقول سميه إذا تسوون زي كذا
موجود يعني
موجود في يوم الخمس يعني بس انه واحد ما لازم تقول معترف فيه خلينا مثلا على المحترم الرسمي يوم عالمي.
Team Saudi Arabia has any question?
Actually, we have suggestions here. It's not actually related to their presentation, but one of our team members came up with an idea. We can share with you guys.
Can you say it again?
Yeah, I said one of our team members came up with an idea related to this conference, but it's not related to the presentation that we just watched.
Now feel free to give the idea. Yes, sure, go ahead.
Yeah, why don't we create a global event to minimize the consumption of water, like what we use in the Earth Day, where everybody shut the electricity down for an hour. Can we use something like that for the water?
I think there are groups who does that. There are some groups who does that. So our objective in our case, we want to. But I know you all these students who have presented are the brightest students in their respective countries and respective schools. So we want to encourage these brightest students to get into higher education, get into research, and be the future of us. So that's our whole idea. So because at NDSU we are a research university, we are in fact among the top 100 research universities in the country right now. In the US, we are among the top 2% universities in the US. So we are a very research intensive university. So we basically want you to come to NDSU when you grow up. When you do your graduate studies, I want you to come to NDSU and do it. And that's the whole purpose we are doing it. We want you to come to NDSU. And that's why we want you to focus on research methodology, so that when you come to NDSU, you are already familiar with what our expectations are, and we can do a better job together.
Sir, we have a question.
In any language, not a problem. Someone will translate it to English.
আমরা শুনেছি যে বাংলাদেশের জলে আর্সেনিকের পরিমাণ খুব বেশি। এটা নিয়ন্ত্রণের ওখানে সাধারণত কি করে?
Okay. I think we do not have the team Bangladesh here, but the question was, in water in Bangladesh has a lot of arsenic. What do they do to remove arsenic in Bangladesh? So I don't think we have team, but I can answer the question for you. So arsenic is a major problem not only in Bangladesh, but we have arsenic problem in North Dakota and other parts of US. We have problem in Assam as well, India, many parts of India. Arsenic is a major problem. Arsenic is naturally present in water, but then when water level goes down, they get oxidized and they get dissolved in water. That's what happened in Bangladesh. Bangladesh, they had arsenic in water, but then when started operating their tube wells for extracting water, water level has gone down and arsenic layers, natural organic got oxidized and got dissolved into water, then they have problem. Now how they remove it? In fact, a professor from Lehigh University, who happens to be from India, he got the Nobel equivalent in water treatment studies. So he is Dr. Sengupta. So Dr. Sengupta got the equivalent of Nobel Prize in this area, and they have developed a technique which is very much in use in Bangladesh. They are using iron as a removal technique. So they are using iron to absorb the arsenic. So arsenic is a complex thing. They use different techniques. They can use metal. You can use iron to remove it. Iron means loha in Assamese. So iron, they can use iron, or you can use other chemicals, or you can use reverse osmosis to remove arsenic. So there are a lot of techniques they use. Also, they use a circle to remove arsenic in Bangladesh, depending on how much arsenic you have. Any other question? Now you can feel free to ask us, or do you have any comments for anybody else? I'll give a maybe a few seconds to Team Tezpur. Do you have any comments?
Sir, I have a question.
Yeah, go ahead. Apa question?
Sir, কেনেকৈ ফ্ৰিকুৱেণ্ট ৱাটাৰ ওপৰত যে ৰিচাৰ্চ কৰিছে কেনেকৈ ৰিমুভ কৰিব পাৰে সেই ফ্ৰিকুৱেণ্ট ৱাটাৰ আপুনি ড্ৰিংকিং ৱাটাৰতে পৰিষ্কাৰ কৰিব পাৰি নেকি বাৰু ফ্ৰেকিং ৱাটাৰ
আচ্ছা ফ্ৰেকিং কি আকৌ কোৱাচোন প্ৰশ্নটো
কেনেকৈ যে ফ্ৰেকিং ৱাটাৰটো যে ইউজ কৰিছে তাৰ ওপৰত কেনেকৈ ৰিচাৰ্চ কৰিছে কি ফ্ৰেকিং ৱাটাৰ আপুনি ড্ৰিংকিং ৱাটাৰতে পৰিষ্কাৰ কৰিব পাৰি নেকি বাৰু
The question was, you have done work on fracking water, right? Can you convert the water now to drinking water? You can answer. Go ahead. What will be the steps? What do you think you have to do to convert it to drinking water?
We have to take out more chemicals than we already have, like more metals. We only did copper, but there is more metals within the water, and we'd have to adjust a lot to make it drinkable.
And the answer was, they have not really thought deep into it. I think that's a good proposition for you. Maybe you can think of next project, maybe converting your fracking water to drinking water. And we'll supply them water from here. We'll send them a month before. They will all drink, right? Then you can know whether it affects others or not. Okay, I think that's a very good question. I think fracking water can be converted to drinking water if there's a need. Take, for example, the presentation made by one team from Nagaon and team from Wisconsin. They, in fact, presented how urine can be converted. Human urine can be converted to drinking water. So, in outer space. So, in fact, that's true. In the astronauts, they go to outer space. They literally, not literally, they drink urine of their own urine by purifying it. So, if there's a need to do that, if there is less water, we'll definitely go for converting fracking water into drinking water. There will be technology. And there are technologies available to do that.
Thank you.
Any other question?
We just have a comment. We just wanted to say thank you for the opportunity to, it was a great experience just to learn about everybody else's projects too. Yeah.
Okay, thank you. Any other comments?
Well, we learned many things from this project. It helped us to teach many things regarding water. We learned the value of water, and moreover, it teaches us many things like how to work in group and all.
Okay, thank you.
And thank you for giving us this opportunity for working in this project.
And by the way, before we leave, I have a request for you. Dan from Minnesota Public Radio must have contacted you, right? He must have sent you an email requesting interviews with you. Please respond to the email, because that way it will help us to get better publicity about our program. Then we can do it in more countries. So kindly respond to the email and give him interviews. You can still use Skype or Polycom. Polycom, can we keep the Polycom for a few more days with them? Yeah. We can keep the Polycom for another week with you. You can use the Polycom to talk to Dan. Dan is number 6. So I'll tell Dan that you are ready. So you can talk to him, schedule a time, or go use Skype to talk to him. Anyway? And thank you everybody. On behalf of North Dakota State University, I thank all of you for this opportunity to bring you together. I know it is a lot of work. We worked all together at night, during daytime, you know. It's a good experience. And it's a sort of a flawless presentation today. We didn't have any hiccups, which is very good. So I thank you again for your, I know it is quite late in India and Bangladesh. And Saudi Arabia also, there's a dinner time now. So thank you again for your time. And this project we have done, the US part, we have been able to support to a certain extent from a grant from National Science Foundation. And we hope that we'll be able to get some other grants to support all the groups across the globe later on. Okay, hope to see you again, and you can start thinking about next year's project and try to recruit more groups. Thank you.
Thank you. Thank you.
Good job, guys. Very good job.
Disconnect.